So now let's speak about the inspiration, the process of inspiration. We have spoken about the difference in pressures, the role of intrapulmonary pressure to keep the lung and the chest wall in their situation, the Boyle's law and its relation with the volume of the container and the pressure of the gas. All these were about introduction to the process of inspiration. So the process of inspiration is taken or is performed by the help of specific muscles. They are called inspiratory muscles. The inspiratory muscles include the diaphragm, the external intercostal muscles, the sternocleidomastoids, and the scalenes. All these muscles are called inspiratory muscles. When these muscles contract, they will cause an increase in size of the chest wall in both directions, vertically and cross-sectionally. When diaphragm contract, it will increase the size of the chest wall in vertical situation, while when the external intercostal muscles, the scalenes and the sternocleidomastoids contract, they will increase the size of the chest wall in a cross-sectional direction, like that. Okay, so after contraction of the inspiratory muscles, and there will be an increase in size of the chest wall as a whole in both directions. So what will occur? What will cause, or what will this help in? After the expansion in chest wall by the help of the active process of contraction of inspiratory muscles, the chest wall will cause pulling force on the pleura. It will cause pulling on the pleura. So when the pleura is being pulled by the chest wall, it will cause what? This will cause the pressure inside the pleura, the intrapleural pressure, which is normally -4, to fall down, to decrease more. So intrapleural pressure, which is normally -4 millimeter mercury, after the inspiratory muscle has been fired and controlled, the chest wall now is what? Is dilated and expanded. So this will cause pulling on the parietal pleura, and the intrapleural pressure will decrease. Intrapleural pressure now will become -7 because of expansion of the chest wall. So when the intrapleural pressure becomes -7, what will this cause? Let's speak about the transpulmonary pressure. The transpulmonary pressure represents the difference in or between the alveolar pressure and intrapleural pressure, as we have said. In normal cases, the transpulmonary pressure is about 4. But now it will become the pressure inside the alveoli, the pressure inside the alveoli at the start of inspiration was 0, minus the intrapleural pressure now becomes -7 because of what? Because of the pulling force of the expanded chest wall. So the final result will be 7 millimeter mercury is the transpulmonary pressure. So we have noticed that the transpulmonary pressure now increased from 4 to 7. So this increase in transpulmonary pressure will cause additional pulling on the lung. So the size of the lung will be increased, and also the size of the alveoli themselves will also increase. The size of the alveoli will also increase. So if the size of the alveoli increase, let's back to Boyle's law. And Boyle's law states that the pressure of a gas is negatively proportional to the volume of container. So the container here is the alveoli. So by this force of pulling of chest wall, and when the transpulmonary pressure reached to above 7, the lungs has been pulled, and also the alveoli have been pulled out and increased inside. So the pressure inside the alveoli decreased because of Boyle's law. When the size of alveoli increased, the pressure of the gas, which was 0 between breath and equal to atmospheric pressure, now after the size of alveoli increased, the pressure inside alveoli decreased. So the pressure of alveoli now decrease and become, for example, -3. And when we increase inspiration like that, whenever we increase, so the pressure inside alveoli will decrease because of increase in their size, and this is true because of Boyle's law. So according to the law of flow, and we have said that the bulk flow equals to delta P on R. So there will be a difference between delta P represent difference between the atmospheric pressure and alveolar pressure. So atmospheric pressure is 0, pressure of atmosphere, minus pressure of alveoli. This is the delta P. So 0 minus -3, it will equal to 3. So now the air will rapidly enter to the alveoli from area of high pressure. 0 is high, so because of the net delta pressure, which is 3. Now the pressure, the gas or the air will flow from outside to the inside of the alveoli because the pressure of atmosphere, which is 0, is greater than the alveolar pressure, which is -3, and net pressure is about 3. So according to law of flow, the air will enter rapidly to the alveoli till all the alveoli are filled with air. And now the inspiratory process has stopped like that. At the point of stoppage of inspiration, and when all the alveoli are filled with air, the pressure inside the alveoli will reach to atmospheric pressure and the process will stop. There is no additional air enter to the alveoli. Why is that? Because of the entrance of the air cause the pressure inside the alveoli to increase and become from -3 to equal the atmospheric pressure, which is 0, so the inspiratory process will stop.